right, hi again everyone. Hopefully you're doing good. We are going to look at page 14 to 15, which you're going to start working on Tuesday. And I wanted to go ahead and make sure you understood kind of how to write some of these I-value equations. I'm not really concerned that much about the equation, but I'll show you how to do it. It's really for the formula, if you've watched lecture 5 notes, that you know how to calculate the I-value. So I'll go ahead and show you the I-value part. So remember, when you have a polyatomic, it's going to count as 1 unless there is a subscript here outside the parentheses. So this would be 1 hydrogen and 1 NO3. So that'll give you an I-value of a 2. Okay, and then we'll go ahead and go down to the second one. So you have a 3 for the hydrogen and then 1 PO4, so a total of 4. And the rest of them should be pretty easy for you to get. Now, how you would write the equation for these is basically they break down into what components, but they have to be ions, meaning that they have to have a charge on them. So this one would break down into hydrogen plus 1 charge, plus the second part, which would be NO3, minus 1 charge. If you want to write the 1, that's perfectly fine, not a problem. Second one, so H plus PO4 with a 3 minus, and you could do 3 minus or minus 3, either one is fine. Okay, then I'm going to move down to one of the molality problems just to kind of give you an idea. There's not a lot of room here to write. You should have enough room, but there's also room at the top of page 15, I believe, for this. So notice they are wanting the change in boiling point, and then they have a second part. They want to know the new boiling point for the substance. So remember that our delta T boiling equals our I value, so I times the constant for boiling times molality. So I'm going to just go ahead and fill them in over here. So change in temperature for boiling. Our I value, notice it's Ki, so 1 potassium, 1 iodine, so our I value will be 2. The constant, which was mentioned in the PowerPoint notes that I went through, 5.12, yes, make sure you take all numbers, Celsius over molality, and then times the molality for the solution, and they tell you that right here, 0.25 m. And we're simply going to multiply all 3 together. And I have forgotten where my calculator has gone. So you should end up getting 0.260 Celsius. So this is your first answer, or for part A, basically, your answer would be 0.26, and then we're going to add that to the new boiling point, or add that to the boiling point so that we get the new version. So all this really means is that the boiling point is going to increase by 0.26 degrees. So for our part B, hopefully you can see this. So for part B, we're just going to say 100 degrees Celsius because that's boiling for water, plus 0.26 degrees Celsius equals my new temperature of 100.26 degrees Celsius. I know, it seems a little redundant, but that's basically the way it is. So not too difficult. Hopefully this helps. Again, I'll post answer keys later. Thanks.